today we will be beginning our new chapter, that is chapter number 3. Okay, we have discussed the previous chapter, the units and measurement, and now we will be talking about the chapter that is chapter number 3, motion in a straight line. Okay, and this motion in a straight line is a part of kinematics. Okay, this is a part of kinematics. This kinematics we have studied till some extent in our class 9, okay, about this kinematics. So firstly we need to understand what actually this kinematics means. Okay, what this actually this word means. Can any one of you can reply me that what you people have studied in your previous classes in class 9 about kinematics? That what is kinematics? How will you define that what is kinematics? Anyone? Anyone is there?
Sir,
Sir, it is the study of motion.
Yeah, it is the study of motion. But there is also one thing which we need to take into our account is that the motion of the body should not be under any type of the force. Okay, that the motion of the body firstly it should be like that. According to this chapter, that the motion should be in a straight line. First point is that. Second point is that a motion should have no constraint. Okay, it should not be influenced by any type of force. Okay, so that is very important to study this branch of kinematics. Okay, so if someone asks you that what is kinematics, so a person first should know that what is the definition of kinematics. Okay, so it is a branch of science or it is a branch of mechanics. Okay, if we are studying about kinematics, then this word has some meaning inside it. Okay, this word has its origin from Greek basically, and if we split this entire word, then it can be split into two parts. One we can split this in kind, and the other can be split in matics. Okay, so kind basically stands for motion. Kind basically stands for motion of an object. Okay, and this matics stands for maths or mathematics. That means what we'll be doing in this, we'll be studying the motion of the chapter with the help of some mathematical tools. Okay, because to learn physics, maths is also very important. A person who is dealing with physics should also know chemistry, should also have some knowledge of mathematics. Okay, because in this you people might be knowing that in the previous class we have studied equation of motions. Okay, in that equation of motions, from where did those equation of motion has come? That may be a question mark in front of everybody minds. So from there we can get that the equation of motions can be derived with the help of some mathematical tools. And in this chapter we will be talking about two types. We will be talking about two methods, that how we can derive the three equations of the motions which we have studied in our class 9. If you people are in your class 9, then you have studied the derivation. As far as I know, because I am also teaching in 9th, as far I know that there is derivation of three equations of motion with the help of graph. Okay, so that also we'll be studying here. But apart from that, what we'll be studying in extra now, we'll be studying the derivation with the help of second method now, and that is the method of differentiation and integration. Okay, that we should have some knowledge of. It is very brief. We should have a very brief knowledge of differentiation and integration. I'll be writing some formulas, okay, as we have written in the past lecture to study units and measurement. Similarly, to study this chapter also, to study the derivation of equation of motion also, we will be doing or we will be taking some formulas of integration and we will be taking some formulas of differentiation. Okay, so in this kinematics basically we deals about the motion of an object with the help of mathematical tools under no influence of force. Okay, there should be no force we should act on it. So how we can define that what is kinematics? Kinematics is a branch of mathematics. It's a branch of mechanics, one can say. Okay, it is a branch of mechanics, because we are talking about the motion. We are talking about the motion. In that, we will be talking about velocity. We will be talking about speed. So it's a part of mechanics. Kinematics is a branch of mechanics in which in which we study about the motion of an object, about the motion of an object without the influence of any force. Okay, without the influence of any force. Okay, so this is the basic definition of kinematics. This is the basic definition of kinematics which you people can write, or if someone asks you, then you can reply him. Okay, so in this kinematics, what we have seen about the motion, which is not having an influence of any force on it. Okay, and with the help of mathematics, we are studying it with some mathematical tools. We should have knowledge of that. Apart from it, if we can see in this kinematic, if we see about the motion, then we can basically define that what is motion. Okay, we can define that what is motion and what is rest. Even a student of class 6 also can define. Even the student of class 9 can also define. Okay, so how will you define motion? I am not writing the basic definition of motion because everyone knows that what is motion. Okay, if there is a change in the position of the object, if there is a change in the position of the object with increasing time, then our body is supposed to be in motion. ठीक है, जब हमारे बॉडी का पोजीशन क्या होगा, समय के साथ साथ क्या होगा, चेंज होता रहेगा, तो उस दौरान हम क्या कहेंगे कि हमारा बॉडी क्या है, मूव कर रहा है और हमारी बॉडी के अंदर क्या है, मोशन है. In the same way, contrary to this, okay, contrary to this, we can define rest also. Okay, we can define rest that if the position of an object do not changes with respect to time, then in that case what we can say, that the object is in rest. Okay, the object is kept at certain place, is not changing its position. For example, we can give different examples. If I am holding this mobile and I have kept this on the podium, so until or unless I may apply any force on that mobile, it will not change its position. It will remain, it will be there only. Okay, if I leave it there and I come back tomorrow to see the mobile, then the position, if someone do not touch the mobile, then the position will remain at that position where I kept that. Okay, so this is the basic definition of rest also. So now if we are talking about motion, okay, if we are talking about the motion, then motion can further be divided into different types. Okay, motion can be divided according to our syllabus. Motion can be studied in different types. That motion of an object can be of one dimension also. Motion of an object can be of two dimension also. Similarly, the motion of an object can be of three dimension also. So if you people have written this thing and you people are understanding everything, then just write it down so that we may proceed further by erasing it. Okay? Still, is there any doubt?
No,
Okay.
No, sir.
Okay.
no, sir.
Okay, just note it down then. So, as I told you that what is motion, I'll be writing that definition so that you may people put it down in your copies. So, if the position of the object of an object changes with time, then the object is supposed to be moving. Then the object is supposed to be moving. This we have to, this I have told you. Okay, and I have told you the definition of rest also. Just contrary to this definition. Okay, just one motion. Now let us talk about the definition of what? About the types of motion. Okay, according to our syllabus, motions are divided into three types. Motion can be of three types. Okay, motion can be of three types. This you can write. For example, which type of the motion? First is 1D motion or one-dimensional motion. Second is two-dimensional motion, 2D motion. Third is 3D motion. Okay, so the motion can be of three types. Now, what is 3D motion? What is 1D motion? What is 2D motion? This we need to understand. And for better understanding of 1D motion and 2D motion, we should have some knowledge of Cartesian coordinates. Okay, we should have the knowledge of Cartesian coordinates. How many of you know that what is Cartesian coordinates? How many of you know?
XYZ planes only.
Okay, there are some dimensions. Okay, these dimensions are not those dimensions which we have studied in our previous lectures. Those dimensions were the powers, but these dimensions show the direction. Okay, these dimensions show the direction of the motion. For example, if I am standing in a room, okay, if I am standing in a room and I am moving, suppose that so it is obvious that if I am there in a room, then my room may be having some length in it, some breadth in it, and at the same time my room may be having some height on it. Okay, so just to analyze that what is 1D motion, what I am doing is I have just started moving along any length. Okay, I have just started moving along the length of the room. For example, I started my journey from this corner and I went straight away to that corner. So in that case, out of the breadth and out of the height and out of the length, along which parameter I am moving? That may be a question. So just tell me along which parameter I am moving if I have opted that length to move. Obviously, I am moving along the length. Okay. If I am moving in a straight line along the length of the room, then in that case, only the motion, only the position with respect to the length is changing. Okay. Are you people understanding what I am saying?
Yes, sir.
Okay. So during that period, the position along the length is changing. I am not moving apart from that length. I am not moving toward this side. I am just taking one edge along the length of the room, and I just started walking from that point till the end point. So let us suppose that the length of the room is considered to be along the x-axis, okay, and the breadth of the room is considered to be along the z-axis, and the height of the room is supposed to be along the y-axis. Okay, that's what I am considering. Okay, that's what I am considering. So during such type of the motion which I did, in that case what changes? Only the length changes. If I started the journey from this corner, I went till this corner. Only I moved along this length only. I didn't move here along this side, along the breadth of the floor. Okay, so during that position there is only change in the length. So such type of the motion which I did, if I traveled along any length, if I traveled along the edge of any length without moving zigzag, such type of the motion is said to be which type of the motion? One-dimensional motion. But let us suppose another example of 2D motion. Let us assume that there is one small child. So in the initial period of his journey of his life, what he do? He never start walking in a straight way. He always starts his journey of life by crawling. Okay? अगर हम किसी बच्चे को जमीन पर छोड़ देते हैं तो वो क्या करेगा? रेंगेगा, ठीक है, क्रॉल करेगा. Okay, so in that case, if I leave it on the floor, so our floor is supposed to have how many dimensions? It should have some length and it should have some breadth. Obviously, our floor may not have any height. Our floor is very plain, so it has its length, it has its breadth. So while we leave our baby inside the room, so he may crawl like this. Okay, he may crawl in a zigzag way like this in a curve. So he may move along the breadth also. He may move along the length also. He may go to and he may come fro like this. Okay, he may do a zigzag motion. Okay, in a random way. So such type of the motion in which both the coordinates are changing. Okay, the length coordinate is also changing, the breadth coordinate is also changing. But the third parameter remains fixed. There is no variation in the third parameter. Baby is not jumping. Baby is not jumping while crawling. Okay, because he is not that much big. So such type of the motion involves the change in the coordinates of the two axes, that is length and the breadth. So without changing the other third parameter, he has defined his length in these two parameters only, in these two lengths only, in the length and along the breadth, in the two dimensions only. So such type of the motion is supposed to be what?
2D.
2D motion.
Two-dimensional motion. Okay. So there is an example of baby crawling on the floor, which is an example of two-dimensional motion. Similarly, if you are talking about three-dimensional motion, then can any one of you can give me the example of three-dimensional motion? What is in practically what how we can analyze
So motion of particles.
Every
motion of
sir,
particles?
so every
Yeah.
They're
sir,
flying.
so every motion in life is 3D motion only. Every type of motion in real life is 3D motion only.
Every type of motion.
Sir, aeroplane.
Yes, sir.
Why?
Sir, if sir, like you give an example of a baby, na? That baby when if you will leave that baby on the ground, so he will crawl here and there. So that baby will also having a height, and also he's moving in like X and Y plane only.
Matter baby is having his height, but if he will not jump, if he will remain crawling, so in that case, at any cost, he will not leave the floor. He will not leave the floor. At any cost, he will not be leaving this floor. Okay, he may not fly like this and come back. Okay, if he stand like this also, then the point of contact is his legs. In the same way, when he crawl, the point of contact is the two legs and two hands, which are still there on the two-dimensional floor. Okay, so you cannot say that every type of the motion is three-dimensional motion. That boy, I think that Aditya told the correct one. Okay, Aditya told that the motion of a particle in a room or the motion of a particle is a three-dimensional. Okay, for example, if I am standing in this room, then I can breathe just because of the random motion of the oxygen molecules which are present in this room. Okay, if oxygen would be static on this floor only, then I need to go to that floor and I need to smell that oxygen to take my breath. Okay, to take proper breathing. But I am not doing that. Wherever I go in this room, whether if I go to that corner also by taking the stairs, so there also I'll be getting the oxygen. If I went back down, there also I'll be getting the oxygen. If I go to that corner, then also I'll be getting the oxygen. So the motion of the particle are supposed to be found everywhere inside this room. Okay, the motion of the particle is supposed to be everywhere inside this room. So such type
So
of
we
the
can
motion in which a particle is moving as such, a particle of gas is moving as such that it can move in a random way. It is covering the height also, it is covering the length also, it is covering the breadth also. Okay, that means during the motion of that object or during the motion of that particle, what is happening? All the three coordinates are changing continuously and randomly. Am I right? How many of you are?
So if we move our hands sir in air, so that also in a 3D motion only, na? So because at that time also all the axes are changing the,
Please
every
speak
time.
a little bit loud because I'm not getting your voice.
Sir, I mean that like our movement of hand in like air, in outside air, sir, that is also in 3D motion only. So because that time also every like
Yeah,
all
that
the
is 3D motion. Your movement of hand with respect to this room is 3D motion. Obviously, that is 3D motion. But I am talking about your legs. I am talking about the point of contact which is there with the floor. Obviously, if you move your hand like this is 3D motion. It is changing its position. It is going along the height also. It can move along the length also. It may move along the breadth also like this. But I am talking about the point of contact with the floor. So in that case, no, if you are not jumping like this, if you are not jumping like this, then you will remain there on the floor if you walk normally. Okay.
Sir, I have a
Sir.
question.
So what we have done, we have explained well that what is the basic definition of one-dimensional motion, what is the basic definition of two-dimensional motion, and what is the basic definition of three-dimensional motion. And we have considered many examples also. Okay, we have discussed and interacted with many examples also. Now we need to write the definition. Okay, it is basically 1 or 2 line definition, so it will be much better for you if I write the definition and you may mention it in your form. So, in defining the motion, we are having 3 coordinates. Okay. Since I told you the first example, according to that, if I'm moving along the length, so in that case, only one coordinate may vary. Okay. Only the one coordinate may vary, and the other coordinates, that is the breadth and the height of the room, remain fixed. Okay. So we can write down that in one type of 1D motion, what happens? One out of two coordinates changes with respect to what? With respect to time. With respect to time. Similarly, two out of one out of three coordinates. Here it should be three coordinates. Okay. One here, what happens in the case of 2D motion? Two out of three coordinates changes with respect to time. Okay, these things we have discussed. And in case of 3D motion, what happens? All the three coordinates changes. All the three coordinates changes with respect to time. Okay, so this is the basic definition of 1D, 2D, and 3D motion. Okay, we have discussed many examples, and your homework is what? You need to find out some more example regarding 1D motion, 2D motion, and 3D motion. Okay, that I'll be asking you in the next lecture. Okay, so let this much be for
Sir, what
today.
is WRT?
Let this much be for today. Okay, because your biology teacher is standing.